Good day everyone. Let's start our discussion by recalling the formula for the volume of a cylinder. And the formula to get the volume of the cylinder is pi r squared h. Now we have a question here. What is the relationship between the volume of a cylinder to the volume of a sphere? And we have the second question is, what is the relationship between the volume of a cone to the volume of a sphere? Given that the height of the sphere, cone, and cylinder are equal and the radius of the cylinder, cone, and sphere are also the same. Let's watch a video on the relationship between a cylinder and a sphere.
In this video, we'll demonstrate the ratio of volume of a cylinder and a volume of a sphere. We have a cylinder and a sphere with the same height and diameter. Fill the cylinder with water. And push the ball into the cylinder. The volume of the water left in the cylinder is a third of the original volume. That means the volume of the sphere is 2/3 of the volume of the cylinder.
The link of this video is also in the description part. So in the video, we conclude that the volume of the sphere is 2/3 of the volume of a cylinder. Let's watch another video on the relationship between the volume of a cone to the volume of a sphere.
In this video, we're going to discover where the formula for the volume of a sphere comes from. In a previous video, we saw that it took two cones to fill a sphere with the same radius. So we'll now go back to recall the volume of a cylinder. And if we remember, the area of the base is pi r squared, since the area of a circle is pi r squared. And we can get the volume of that cylinder by multiplying by the height. We later learned that to get the volume of a cone, we would take the volume of the cylinder with the same height and same radius and simply divide it by 3. As we saw in the experiment, it took two cones to fill up a sphere with the same radius. It's important to note that that would mean the height of the two cones would be the same as the height of the sphere. And the radius of the two cones would be also the same as the radius from the sphere. So what this really means is that we could find the volume of one of these cones and simply add another volume of a second cone to determine the volume of a sphere. But this isn't necessarily the most efficient way. If we analyze the relationship between the radius of the cones and the height of the sphere, we'll see that 2 radii is equal to 1 height of the cone and 1 height of the sphere. So rather than calling the height of the cone h, we could essentially replace h with r plus r, or 2 times r. Following mathematical convention, we'll bring the coefficient of 2 to the front of the term. And simplifying r squared times r, we get r cubed. Simplifying further, we'll notice that we have two fractions, 2/3 pi r cubed plus another 2/3 pi r cubed. So let's write this a little differently to make it look a little easier to work with. While we can likely see that 2/3 plus 2/3 is 4/3, let's put them together to make this a little more obvious. Since we have a common denominator of 3, we could put our 2 plus 2 in the same numerator over one denominator of 3 to get 4/3 pi r cubed, which can also be written as 4 pi r cubed over 3.
The link of the video is also in the description part. So in the video, we can also conclude that the volume of a sphere is twice the volume of a cone. Therefore, we can say that the formula to get the volume of a sphere is 4 pi r cubed divided by 3. So our lesson is on how to find for the volume of a sphere. Now let's apply the formula to get the volume of a sphere in our examples. First, we have here find the volume of the figure with the diameter of the sphere, which is 10 inches. Now using the formula, which is 4 pi r cubed divided by 3, we only need, the dimension that we need is the radius. And since the given is diameter, which is 10 inches, we have to divide into 2 to get the radius. So if the diameter is 10 inches, the radius is 5 inches. Then we substitute, so we have 4 times the 3.14 for the value of pi, then the radius is 5 inches. Then you multiply the number 5 or the radius 3 times by the number itself. So we have here, multiply this first or get the cube of 5 inches. So we have 5 times 5 times 5, we have 125 cubic inches. Then after that, you can multiply these 3 values. So 4 times 3.14 times 125, we have 1,570 cubic inches. And after that, we divide into 3. Then our answer here is 523.333 cubic inches. So here, there's a repeating decimal. So we can end up to 2 decimal places. So we can write 523.33 cubic inches. If it's repeating decimal, you can end up to 2 decimal places only. Next, we have a ball has a diameter of 14 centimeters. What is its volume? So using the formula, still the same, 4 pi r cubed divided by 3, we have 4 times 3.14 times 7 centimeters for the radius because the given is diameter. So you have 7 centimeters and you cube the 7 centimeters. So we answer this first. So 7 times 7 times 7, we have 343 cubic centimeters since we multiply 3 measurements and then we multiply this 3, our answer is 4,308.08 cubic centimeters. Then we divide into 3. Our answer here is 1,436.026667 cubic centimeters. So in this case, you can round this off this hundreds place. Okay, so the final answer, since we will just answer up to 2 decimal places, so the 2, this 2 becomes 3 since beside it is 6. So 1,436.03 cubic centimeters. Next, find the volume of the figure. So as you can see, it is a hemisphere or half of the sphere. Then if it's half of a sphere, what we're going to do is we get the volume of the sphere first. So using the formula. Then after that, we're gonna divide it into 2 because again, a hemisphere is half of a sphere. And we have 6 centimeters as the radius. Then you cube the 6 centimeters. We have 216 cubic centimeters and multiply 3.14 times 4. Multiply the 3 values. We have this 2,712.96 cubic centimeters. Then we divide into 3. Our answer is 904.32 cubic centimeters. Then we divide it into 2 since it's just only half of the sphere or hemisphere. We have the volume 452.16 cubic centimeters. Next, we have here a word problem. A bowl in the form of hemisphere is 4 inches in radius. How many cubic centimeters of soup will it contain? Okay, so using the formula for the volume of a sphere, we have 4 pi r cubed divided by 3, substitute the given. the radius is 4 inches, then you cube it. So we have 4 times 4 times 4, you have 64 cubic inches, then multiply 3.14 and 4, we have 804.84 cubic inches. Then we divide into 3, we have 267.94667 cubic inches. Then we divide into 2 since it's just only a hemisphere. So we need to find the volume of this bowl. Then the volume is 133.95 cubic inches. So this is the volume of the bowl. So that's about the lesson on the volume of a sphere. I hope that you learned something from this video.